This presentation serves as operator training for the AJA Dielectric Sputter system in the K&I. In this we will cover all standard necessary procedures for creating working recipes and operating the equipment. This sputtering system is UHV, with an ultimate base pressure less than 5e to the -9 torr. The wafer loading is fully automatic. Substrate heating is achieved by direct radiation to the back of the wafer and can sustain temperatures up to 800 C uniformly across a 6-inch wafer. RF bias up to 100 watts can be applied to the substrate for in situ cleaning, oxide removal, and etching. This may be performed with any of the available process gases. There are 8 sputter guns, where 7 are 2-inch cathodes confocally oriented at an angle toward the substrate for uniformity across 6 inches with rotation. There is one 3-inch centrally located gun which faces directly at the substrate. This gun is not uniform over the entire wafer, but rather is only uniform at about 2-inch diameter relative to the center of the holder. There are 2 RF power supplies and 3 DC supplies, one of which is a pulsed power supply meant for reactive sputtering of dielectrics. Process gases are semiconductor grade argon, nitrogen, and oxygen. Process pressures are controlled downstream, which enables independent control of process gas flow rates and total process pressure. The pumping systems are completely dry for the lowest possible contamination. The automatic recipe creation is very powerful, allowing complex processes involving hundreds of layers. Prior to operating, check the following and correct as necessary. If the cryopump temperature, turbo speeds, chamber pressure, or power supply output are not correct, notify K&I staff. You'll notice there are 2 electronics racks. One is tall and kept behind a plexiglass door, and the other is shorter and directly below the monitor and keyboard area. At the smaller electronics section, verify that the cryo temperature is less than 15K. Check the speed of each turbo. They should be approximately 820 and 1500 Hz. Check the output of each RF power supply. They should all be outputting 0 volts. On the tall electronics section, make sure that the substrate temperature holder is set to remote mode. You'll find the adaptive pressure controller in local mode. Hold the remote button until the LED on the button turns green to put it in remote mode. You will need to do this in order to control the pressure with the software. Check that the main chamber pressure is somewhere in the 1e to the -8 range. Check that the output of each DC power supply is 0 volts. You'll start off by logging into the software with a provided password. Your password connects to all the layers and processes you will create, so that you can more easily organize your work. After logging in, you will see the following configuration screen, which allows you to set things up in the event that you need to swap power cables around to different guns. I will train you if this is something you end up needing to do. Otherwise, do not alter anything on the screen and simply hit Config Save Close to move on. This is the main control screen. From here you can operate every control manually if you need to test something out. At the top there are 3 buttons to navigate to other screens. They are Create Layers, Create Process, and Run Process. Most users will only use this screen to initiate loading and prepare the system to run an automatic process. On the coming slides I will break down these controls and the functions of the other screens so that you can access and create and run processes. At the top we have control over rotation, substrate heating, gas flow, and pressure control. The buttons at the top left let you log out and go back to the config screen you saw immediately after logging in. Moving to the right is substrate rotation control. With rotation enabled, the heat section to the right of that will become usable. You enable substrate heating by pushing the button next to heat. Click that button and then you can put the desired set point and ramp rate in. If no ramp rate is entered, it will ramp as fast as possible. This is about 2 Celsius per second. Note that any time there is a set of ramp and set point inputs, you must always enter the ramp value before you enter the set point value, or it will not take the ramp time. Always press enter after you type in a value in order for it to take. To the right of that are controls for the mass flow controllers. Each one says which gas they flow and the maximum flow rate you can set. To flow gas, simply type the desired flow into the set point box and hit the button next to the gas number at the top. Next we have pressure control. The pressure is controlled by a throttle valve in front of the main chamber turbopump. This control section works with that valve. You can open or close it, set it to a specific position between fully opened and fully closed, or set a desired pressure between 0.5 millitorr and 100 millitorr. To operate it, simply select the control mode you want and enter the desired value. The last section controls valves which route gas from the mass flow controllers to different entry points in the chamber. Notice that the first three say argon to guns 1, 5, and 8. These valves inject gas into the chamber through the gas injection rings for those guns. It's recommended that you flow argon into these guns whenever you are using them, especially when flowing oxygen or nitrogen to form compounds. If you are using guns without a valve to them, it's recommended that you flow gas in through gun 8, as it is centrally located and equidistant from all the other guns. Nitrogen can flow in through either gun 8 or the substrate distributor. Notice that oxygen does not have any valves. When oxygen is flowing, it comes into the substrate distributor only. This section allows us to initiate automatic sample load and unload, control some gauges and valves, and set our substrate height for our process. When the load lock is below 2e to the minus 6 torr, we can load the chuck very simply by hitting the execute button where it says load and unload. This takes about 1 to 2 minutes. Once you initiate it, you will see most of these controls gray out so that you can't interact with them. Don't try to do anything else while loading occurs or you may cause it to freeze. Once the sample is loaded, you'll be able to push the execute button again to unload. With the chuck in the main chamber, we can set our desired substrate height. 0 sets the manipulator all the way up and is furthest away from the guns in position. The largest value you can set here is 2.9, which means the sample is 2.9 inches down from the top. This is not the distance between the guns and the substrate. Be aware that due to the configuration of our system, the best thickness uniformity is achieved at a height setting of 0.75. If you are using the center gun, which faces directly towards the substrate height can be used to achieve much higher or lower rates. Here we also have controls to turn the ion gauge on and off, and to actuate the cryo-isolation valve. We will use these right before we start processing, as neither the cryo pump or the ion gauge are useful during sputtering. You'll also notice that these home buttons for the substrate height and the transfer arm position are currently green. After an abort or another type of error, you will need to home these, and they will flash yellow and red. Just click them and wait for them to finish homing in the event that that occurs. The transfer valve button actuates the valve between the load lock and main chamber. This isn't a button you will need to use, but it is nice to use as an indicator for the current status of the valve. Lastly, there's an indicator for the cryopump temperature, which should be less than 15 K at all times. Now that we've seen the tools needed to load our sample, let's go over that. First, you'll want to set up the work area in front of the load lock. Clear the area and lay down 2 clean tex wipes. You may need the Torx driver shown on the wipes if you plan to mount small chips to the holder. You can find this in the white drawers between the 2 sputter systems. Clean your tweezers and other tools with IPA. It's best to keep your containers for holding wafers and chips clean of any fingerprints as well. Clean them with IPA if you are not confident they are clean before continuing. Check the section of the control screen which shows the status of the load lock transfer valve. See that it is closed before proceeding. Then locate the breaker for the load lock among the electronics. Flip the breaker down to vent the load lock. This will take a few moments as the turbo slows down and the load lock vents. Note, as the venting starts, pay attention to the main chamber pressure and the load lock pressure. If the main chamber pressure begins to rise, you must immediately flip the breaker back up to stop the vent and begin pumping instead. This happens if a flake of metal or sometimes a small piece of a wafer gets in the way of the transfer valve actuation, therefore causing a leak. If this happens, notify K&I staff and do not proceed. Put on a second pair of clean gloves. From this point on, be careful not to touch anything other than your clean tools and sample boxes, and the handle for the load lock lid. Once the load lock pressure is greater than 730 torr, you will be able to lift it. Lift the lid and place it face down on the 3 rubber feet on the table as shown. Please be careful not to scratch the underside of the lid on anything, or it may be damaged so that it cannot form a vacuum-tight seal. Lift the holder out of the load lock. Note that it's made out of multiple parts which rest against each other and only stay together under gravity. It will easily fall apart if you flip it over. Remove the appropriate components of the holder to take your wafer size. It can hold 6-inch, 4-inch, and small pieces depending on which parts you remove. Place the holder parts back onto the load lock so that they rest flat in the circular groove on the transfer arm. Put the lid back on and flip the breaker up to begin pumping the load lock. Once the pressure is less than 2e to the minus 6 torr, you can hit the execute button on the main control screen to initiate auto loading. Don't do anything else with the software while you wait for it to load, or you may cause it to freeze. Now let's take a look at the power supply controls. Each box corresponds to a power supply. At the top you'll see the supply number and type, such as RF1 or DC1, as well as the gun and target they're connected to. Also near the top there is a counter for the total amount of energy in kilowatt hours that has been applied to this specific target. This is used for estimating when a target will need to be changed. On each control you can input the desired ramp time and power set point, open and close shutters, and enable the power output. The control for each gun also provides feedback about the current parameters, such as the output voltage, power, and current. Some power supplies have a switch drop-down menu, which allows you to select the current switch position for that power supply. This lets you change which gun that supply is currently connected to. Note that you can only switch these while the gun is off. For DC supplies, you can also change the operation mode to run in constant power, constant voltage, or constant current mode. To select, click the drop-down menu next to Mode. DC5 is a little special. It has the option of running in a pulsed mode, which means that it is like a square or pulse wave, where you can perform pulse width modulation. This mode can be ideal for reactive sputtering of dielectrics. When in pulsed mode, the frequency and pause duration can be adjusted. To select pulse mode, use the drop-down menu at the top of the DC5 control. See the supplemental reference material link in the description for more info on the limits of these controls. Now that we've covered the gun controls, let's go through a simple example of striking plasma manually. First, we will need to turn off the ion gauge and close the gate valve to the cryopump using their respective controls. Next, set the argon flow to 30 SCCM. Hit enter and click the on-off button to turn it on. Then set the pressure controller to pressure mode, type in 30 and hit enter. This will set the pressure to 30 millitorr. Next, open the flow valve to the desired entry point. If the gun you're using has no entry point, then simply flow to gun 8 as a default. On the desired gun control, set it up as you like, including all pulsing parameters and switch positions. Set the power set point to 30 watts and hit enter. Then click the on-off button above output to turn it on. Note that when striking a plasma, we do not want to enter a ramp value, as we want the power to come on suddenly. Only do this when striking, since the power is generally pretty low. You should observe the little indicator above the output button turn purple after only a few seconds. You can also peek into the chamber through one of the viewports briefly to check that the plasma is lit. Note that you must never sputter with any gun or ignite substrate plasma unless the substrate holder is loaded. Behind the holder there is a glass window that must be covered and protected against coating and etching. Now that we've seen a bit about operating the guns, let's take a look at the Create Layer screen. Here we can automate operations like the ones we just performed to strike the plasma. On the left side, we can save the layers we've created and open up existing ones for modification. There is a control for the substrate rotation speed, substrate heating, pressure control, and gas flow settings. On the right side, we have controls for the power supplies. The top region is for the RF supplies, and the bottom is for DC. Let's go into detail with how these power controls work. They are identical to what you can do manually on the main screen, but they have a specific order of operations on the screen so that you can control them in sequence. All the setup functions accessible via drop-down menus, such as switch position, power mode, pulsing parameters, and whether the gun is enabled to be applied first. Next, the delay time will count down. This is useful for making multiple supplies do something in one layer, with the time offset between when they start. Next, the ramp up and down time will be set. Then the supply will head towards the power set point over the set ramping time. Once the power set point is reached, it will count through the shutter delay time. This is typically used to perform a pre-sputter prior to opening the shutter. If the shutter enable is on, then the shutter will open at the end of the shutter delay. It will then count through the coat time. If shutter carryover is set to closed, then the shutter will close at the end of the coating time. If not, the shutter will remain open as the process transitions into the next layer. The idle set point power is the power that this will ramp down to once the coat time is over. So if you were to set it at 30 watts and you were at 100 watts and your ramp time were 60 seconds, then once the shutter closes, it would ramp down from 100 watts to 30 watts over 60 seconds, for example. Let's take that plasma strike we did manually and turn it into a layer. This is an example of a simple striking layer on a 2-inch titanium target with DC power. Here we have rotation on with a speed of 10 RPM. Pressure control is set to 30 millitorr. Argon is flowing in through gun 1 to the gun containing titanium. The argon flow is on and set to 30 SCCM. Looking at the power supply section, you can see we've selected switch position 1 for DC5, which shows that it's connected to gun 1, which holds a titanium target. The gun is in watts mode and arc detect mode, which is normal DC when using the pulsed power supply. You can see that the delay and ramp time are set to 0. They aren't necessary when striking. The power has been set to 30 watts. Because there's no ramp time, the gun will abruptly apply that power. No shutter delay is needed here because we aren't yet ready to actually coat anything. This is just to ignite the plasma. I don't enable the shutter because we don't want to open it. I've set the coat time to 10 seconds simply to give the plasma some time to ignite and stabilize. Shutter carryover is closed since we never opened the shutter in the first place. And lastly, the idle power is set to 30 simply to keep it at the power that we set it at. So what this recipe does is exactly like what we just did manually. It sets up the gas flow and pressure in an appropriate region for ignition, and then turns on a relatively low power. We choose to keep the power on into the next layer because we want to keep the plasma on while we enter a better process region for sputtering onto our substrate. The next layer we'll create will jump off where we just ended the last layer. This is our deposition layer. I've stepped the pressure down to 3 millitorr, which is very appropriate for sputtering at reasonable rates. I've also turned down the flow rate to 20 SCCM. The combination of 20 SCCM and 3 millitorr is a convention I intend to stick with for the purpose of consistency across various general processes. You can of course deviate from this. Now there's a ramp time of 80 seconds on DC5, and I've set the power to 150 watts. This is in accordance with a general rule I follow for ramping rates, which I will explain later. After the 80 seconds is up, there will be 150 watts applied to the target. Then a 60-second shutter delay is set to clean the target surface and let the target reach a better thermal equilibrium and stable sputter rate. After the 60-second shutter delay, the shutter enable is on, so the shutter will open. It will remain open for the coat time of 200 seconds. Since the shutter carryover is closed, it will close at the end of that 200 seconds. Immediately after closing the shutter, it begins to ramp down over 80 seconds to the idle power of 30 watts, which is the same power at which we struck the plasma in the first place. If this is the last layer in our process, then the gun will turn off. So we want to make sure it's back at striking power before turning it off. Turning power on or off abruptly at high powers can crack targets and damage power supplies, so don't do that. Now that we've seen a basic strike and deposit layer, here's some rules and guidelines for creating them. When striking, the following parameters are generally going to work. In circumstances where they do not, there are some troubleshooting tips provided in the Sputter reference material. Pressure, flow, and power can all be set to 30. For non-metals, ceramics, and bonded targets such as silicon and other brittle semiconducting materials, limit your striking power to 15 watts. The reference material lists maximum powers for each material and its target size. Do not exceed maximum power for the respective material. When ramping, the general rule for metals is 60 seconds per 100 watts. For non-metals and bonded targets, that maximum rate is 60 seconds per 10 watts. For the substrate etch, you can treat it like a metal regardless of material, as the power density is very low by comparison due to the width of the substrate area. For flow and pressure, I attempt to choose the combination such that the position of the pressure control valve is roughly half open. This helps to keep effective pumping speeds relatively constant across different pressures. These listed combinations are general recommendations. For reactive sputtering with nitrogen or oxygen to form oxides and nitrides, I recommend you use pulse DC for any compound that's a dielectric. When performing reactive sputtering, it's wise to try and establish a maximum flow rate of reactive gas before the target poisons. For more information on this, see the link in the description for the Intro to Sputtering presentation. This is somewhat advanced and will be taught more in person upon request. When pre-sputtering, it's recommended that you do about 60 seconds for cleaning off contaminants and unwanted oxide or nitride surfaces on the target that may be left over from a previous process. If you are performing a reactive process, then 300 seconds is recommended for a pre-sputter. This is due to the reactions taking place at the target surface. You will want to let that process reach equilibrium before opening the shutter. So now we have some layers we just made. Let's arrange them in order to create a process. From the main screen, we simply click the Create Process button near the top to get to this screen. On the left will be your complete list of created layers. To add them into a process, simply select the one you want and hit the Add button. You can also drag them around and rearrange them afterwards, or select them and hit Delete to remove. The process will go in order through the layers from top to bottom. Click Save to keep it. You can also click Open to bring up an existing process from your list and modify it or create a different process from it. There's also the ability to create processes and layers in an Excel sheet and import them. I'll show this upon request, as it's generally only useful for very large processes with a lot of layers. Now we're at a point where we've loaded your sample into the main chamber and we've created a process for it. Before we can run that process, we first need to turn off the ion gauge and close the valve to the cryopump. Also check to make sure the adaptive pressure controller is in remote mode. Go to the Run Process screen with the button at the top of the main screen. This window will pop up with a list of all your processes. Simply select the one you wish to run, type in any desired notes, and hit Open. Once the process starts to run, we will see this slightly different version of the main screen. It will show us everything that's currently going on. Also, towards the top right, there's an indicator which states the current process, the layer that it's currently on, the total elapsed time, and the elapsed time for the current layer. This is a snapshot of a reactive sputtering process for aluminum oxide. We can see that the process is currently in the second of 2 layers for the process. The rotation is set to 10 RPMs, argon flow is on and set to 20 SCCM, oxygen flow is on and set to 2.6 SCCM. The pressure is set to 3 millitorr and holding at 2.9. You'll find that there's often some small error in pressure and flow rates. This is normal. We have argon flowing to gun 8, and oxygen is flowing to the substrate. The substrate height is set to 0.75. Looking at the power supplies, DC5 is connected to switch position 2, which is at gun 8 and holding a 3-inch aluminum target. The power supply is operating in constant power mode and is set to pulse mode with a 100 kHz frequency and a 3 microsecond pause duration. The shutter is currently closed. The plasma is currently lit and the gun is in the process of ramping towards 300 watts. At this particular instant, there are 119 seconds remaining in the ramp. The current feedback from the gun is shown to the right, which displays the power is at 98 watts. The potential is at 366 volts, and the current is at 268 milliamps. Since I wrote this process, I am expecting this layer to bring the power to 300 watts. Then it will sit there for a 300-second pre-sputter before the shutter opens for a 1,000-second long coating. The shutter will then close. The gun will ramp down over 180 seconds to 30 watts, and then the process will end and turn off the power to the gun, the gas flows, and open the main chamber turbo completely. It's important that you double check each layer in this process, and that you understand exactly what something is going to do before you do it. And the first time you run a process, pay close attention and triple check that there are no mistakes and that it is doing exactly what you expect. Once the process is done, open the cryo valve and turn on the ion gauge. Then you can initiate the auto unload the same way you initiated loading, by hitting execute. Once the unloading is complete and the transfer valve is closed, you can flip the vent breaker to vent the load lock. Again, remember that the main chamber pressure should not rise at all when venting the load lock. If it starts to rise, then immediately flip the breaker to pump the load lock and notify K&I staff. As the load lock vents, prepare your clean work area if it's not already, and put on a second pair of gloves. Even if you already have a second pair of gloves on from the first time when you loaded, you need to take them off and put a new pair on right before you handle any of the things inside vacuum. Remove your samples, and then put all wafer holder parts back together and onto the transfer arm. Put the lid back on and pump it down. Lastly, set the adaptive pressure controller back to local mode. You may now sign out of the Phase 2 software, finish filling out the logbook, and log out of LabRunner. Finally, let's summarize the entire process of operating this system. First, we will set up and load our samples. This consists of logging in and performing initial checks, preparing your clean work area and tools, venting the load lock, loading samples, and then pumping down. You can transfer the sample into the chamber once the load lock reaches 2 e to the minus 6 torr. Next, we will create our layers and processes. Practically, though, you can do this at any time. On top of programming the desired layers, this involves double checking that your layers match the current gun and target configuration, as the target configuration can change as different materials are loaded by request. Make sure that the power will transition smoothly across layers. Watch out for accidental sudden changes, and be sure you are not going to exceed a target's maximum power. When ready, run your process. Close the cryo valve and turn off the ion gauge. Set your substrate height if necessary. Once your process is complete, open the cryo valve and turn on the ion gauge. Transfer the sample to the load lock, vent the load lock, unload your samples, put the holder back in, and pump down. Make sure you set the pressure controller to local mode before you walk away. Then log out of the AJA software, and you're done. Thanks for watching.